Hello students, today we will read about forces between multiple charges. In the previous class, we read about the two charges. In a particular system of charges, we had two charges Q1 and Q2, and then we derived out a formula for the force which is acting on Q1 due to Q2 and on Q2 due to Q1, and that formula is given by Coulomb's law of electrostatics. So what does the Coulomb's law of electrostatics states? Coulomb's law of electrostatics. Okay, so it states that force between any two charges Q1 and Q2 is given by F equals to K into Q1 into Q2 divided by R square. Here F is the force, K is the proportionality constant, which is given by 1 by 4 pi epsilon naught, whose value is 9 into 10 to the power 9, and then Q1 and Q2 are the charges under consideration, and R square is the distance between the charges, square of distance between the two charges, Pictorially, it can be expressed as Q1 and Q2, which are separated by a distance of R square. Okay, here Q1 and Q2 are point charges because their size is extremely small when compared with the distance between these two charges. Okay, so this was the thing which we have read in the previous section. In this section we will deal with many charges Q1, Q2, Q3, Q4, Q5 up to Qn, n number of charges. Okay, so mutual electric forces between two charges is given by Coulomb's law, as I have already told. Now for calculating charges where we have many charges, let us consider a system of n charges which are stationary Q1, Q2, Q3 dash 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 Qn in vacuum. As already mentioned in the previous classes, in this chapter we will deal with vacuum or air, not with any medium. Okay, not in any medium. If we are introducing medium, the concept becomes little complicated, and for that we have the other unit. Okay, forces of mechanical origin add according to the parallelogram law of addition. So you might have studied in 11th standard that the forces of mechanical origin, like the push, the pull, or the force due to gravity and other forces which we see in our day-to-day life, add up in the way these vectors are added using the parallelogram law of addition. Okay, like this is force 1 and force 2. According to that we will make other two sides, and the diagonal will give us the resultant. Okay, it is verified that forces on any charge due to a number of other charges is vector sum of all the forces on that charge due to other charges taken one at a time. The individual forces are unaffected due to the presence of other charges. The statement here states that in a system of charges, like we are having a system of charges where we have Q1, Q2, Q3, Q4, Q5. Okay, randomly we have these charges. I will name it Q1, Q2, Q3, Q4 and Q5. Okay, so the force on Q1, we will calculate the force on Q1 due to Q5, Q4, Q3 and Q2. Okay, so in this case here the charge which is under the consideration is Q1. We have to find the force on Q1 which is on it due to Q2, then Q3, then Q4, then Q5. It will be the sum of all these charges. It will be sum of all these charges. So force on Q1 will be due to force of Q2 on 1, force of Q3 on 1, force of Q4 on 1, and so on. Okay, but we can say like there is some force on Q2 on due to Q3, Q4, Q5, on Q5 due to Q1, 2, 3, 4. Yes, it is possible in the system every charge will be exerting some or the other force on the other charges. But when we are considering one system, we have to take the individual charge only. At this point, this Q1 will be unaffected of any other force. Q1 will be affected only and only due to the charges Q2, 3, 4, 5 and other available charges. The summation of force on Q1 will come from the force Q2, Q3, Q4, Q5. Okay, there will not be any other complicated formulas. So this is the principle of superposition. When we are like on Q1, one force from Q2, other force from Q3, third force from Q4. So what they are doing here at the Q1, these forces are coming like layer on layer, are superimposing, sitting on each other, right? The stacks of book we keep, like we take one book, then second book, then third book, that is overlapping. And similarly when we see the pictures, when we overlap pictures, all the pictures are visible. That is known as superimposition. Okay, so what is happening here is these forces are coming on each other due to Q2, then 3, then 4, then 5 and so on. So these are getting superimposed on each other, and hence this particular phenomena is explained on the basis of principle of superposition of the charges. Now we will consider a system of 3 charges. See here the diagram. We have origin O, Q3, Q1, this is Q3, Q1 and Q2. Our charge here under the consideration is Q1. This charge we have to find force on Q1. Okay, the force on Q1, the component, like one part of force is due to the presence of Q2 and the other part of the force is due to the presence of Q3. Then these force lines are coming over here and we made a parallelogram here. Using this parallelogram, what we are doing? We are trying to find the force resultant force on Q1. Resultant force on what? Resultant force on charge Q1. So if the force on Q1 due to Q2 is denoted by F12 with an arrow above it. What is the arrow here? This arrow shows the vector nature of the force. Arrow shows vector nature. So here we are dealing with the vector quantities. F bar 12. This F bar 12 in the format of Coulomb's law is given as this: F12 equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 whole square into R cap 12. Here R12 square is the distance between Q1 and Q2. whereas r cap 1 2 is the unit vector. R cap 1 2 is the unit vector. Moving on to the next slide. So similarly, we will see the force on Q1 due to Q3 is given as the Coulomb's law only, and it is given as F13 equals to 1 by 4 pi epsilon naught into Q1 into Q2 divided by R13 square into R cap 13. Here R cap again is a unit vector. Then the total force F1 on Q1 is given as F1 equals to F1 due to charge 2, F force on charge 1 due to charge 3. Total force equals to force on Q1 due to Q2 plus force on Q1 due to Q3. Okay, so this is our second equation, and in the previous slide was our first equation. We will put these equations over here and take out the common things. In this equation, one unit which is common is this 1 by 4 pi epsilon naught, and the other common thing is Q1 in both the equations. Taking the commons out, it is F1, that is the total force on charge 1, equals to 1 by 4 pi epsilon naught into Q1 whole Q2 by R square. Okay, Q2 by R square plus Q3 by R square. And here R, it's not simply R square, it is R12 square, this is R13 square, because the distance of Q2 and Q3 is not same, it is different. So here in this case, what we have explained is, we have explained the case of three charges, a case of three charge system. Just have it thinking for a minute, like if we get n number of charges in a system, then what we will do? Are we going to leave the case as such? No. In that case, we will use this formula of three charges, for n number. Here we have taken F12, F13. Similarly, for calculating for n number of charges in a system, we will take the equation in such a format. Okay. Format is force on a single charge, let it be the charge 1. Force on charge 1 equals to force on charge 1 due to 2, due to 3, due to 4, and keep on going till n. Okay, here F1n, I'll write again, F1n denotes force on charge 1, that is Q1 due to nth charge, that is Qn. Okay. Similarly, F12 denotes force on charge 1 due to second charge. Force, this second value here denotes force on charge 1 due to charge 3. Okay. The common value is 1 by 4 pi epsilon naught and into Q1. Q1 is also common, which will come here. See in this equation, Q1 divided by 4 pi epsilon node into sigma, which goes I equals to 2 to n. Charge 1 is here, so we will not start I from initial number from 1, we will start initial number from 2. The charge number 2 to nth charge, limits are from charge 2 to n number of charges into qi by r1i square into r1i cap. This is again a unit vector, and in the previous class I have told we use unit vector to define the direction, like to define our direction of the vector of this like position vector. A unit vector do not have magnitude, or a unit vector have a magnitude of 1 unit, so it is called a directional vector, and it provides us information about the direction of a given vector. Here what is qi? Qi is charge of ith unit, charge of ith unit, because the limit of I is limit of I. In the formula you can see limit of I is from 2 to n. This thing in sigma I equals to 2, this is initial unit, and we write something on up like n, this is the final unit. So from I should go from 2 to n. Okay, this is this limit, this is how we write the limits. Then we will go to r1i, that is distance between first charge and the ith charge. Again here also the value of I depends upon which number of charge we have taken, and it have limit from 2 to n. Okay, so this is the formula which gives us force on a particular charge in a given system of charges, The vector sum is obtained as usual by parallelogram law of addition of vector. So whenever we are dealing with the vector and we have a number of components to add up in the vector, we use parallelogram law of addition. So similar like in mechanical forces, electrostatic forces can also be added using the vector laws, and the specific vector law which is used over here is parallelogram law of addition of vector. And all of these electrostatics is basically based on the consequences of Coulomb's law and superposition principle. The formula we have derived from the Coulomb's law, the basic Coulomb's law, that is F is proportional to charge and inversely proportional to the square of the distance from this, and then the superposition principle, that a charge over here will start superimposing the forces which are coming from many other charges, like all the component of forces will be superimposed when we are taking care of one single charge. Okay, so these two are very much important in electrostatics, understanding the Coulomb's law and the superposition principle. So this is all for today's class, and in next class we will learn more about these particles in these charges in a system. So here the point to be noted is all electrostatics basically show all these consequences and all these results due to Coulomb's laws application and superposition principles application. Okay, thank you, bye bye.